Thank you very much, Vice Chancellor. Welcome, Elon. It's an enormous pleasure to bring great minds together, and that's why my job as director of the Oxford Martin School is so fun. And meaningful because we are dealing with the greatest challenges of the 21st century. In Elon Musk, we have someone who is focusing on two key areas, transport and energy. He's an extraordinary intellect, but he combines his science with the business acumen and a commitment to society which is unusual. It's the combination of not only business, but also with science and knowing what to apply it for that makes him a really special visitor tonight. An extraordinary talent with the right commitment to deal with the challenges of the 21st century. He's the engineer and entrepreneur who builds and operates companies to solve global environmental, economic, and social challenges. He's the CEO and chief designer of Tesla Motors, you'll see the car outside, and CEO and chief technology officer of SpaceX. At SpaceX, Elon is the chief designer and has overseen the development of the rockets, which have taken it now twice to the space station. They've received the $1.6 billion NASA contract to provide commercial replacement for the cargo, and as he will tell us, no doubt, they have now got a commitment as well to take astronauts. It's the most extraordinary thing visiting the factory, as I was privileged to do, and to see not only the energy and commitment of Elon and his team, but also the originality, just how much of what they are doing is original, how much they are taking away. It has taken governments before. 4 governments have achieved what Elon has achieved. Never before has a private individual done so much, so quickly for space. In addition to his work on SpaceX, as if that wasn't enough, his work at Tesla is developing a car which has now won this year the automobile and the Auto Trends Automobile of the Year. Now, for those of us that don't follow cars, this is the equivalent of winning the the Grammys and the Oscars in the same year, or for us academics, 2 Nobel Prizes. It is an achievement which is quite remarkable, and having driven, he was kind enough to trust his Roadster to me. Having driven one of his cars, I felt like I was in a space rocket. It had this G-force, which I've never before experienced. This car, I believe, will revolutionize transport because it will enable people to see that you can do things without carbon, which were unimaginable before. In addition to this, he started and runs SolarCity, which is developing and now the biggest producer of solar power systems in the US. He began at PayPal, which he co-founded, and all of you will know about PayPal. He became its CEO and then moved on to these other things. The Vice Chancellor mentioned that we have a South African connection. We went to the same high school, and we both escaped. He went from there to do his degrees at Pennsylvania and at Wharton, and in many ways has moved on from that. But the work that he was doing, including on supercapacitors, has continued to drive a lot of what he does today. It is this incredible combination of vision, bravery, and ability which has had him likened by many to a 21st century version of what Brunel was in the 19th century and Henry Ford in the 20th century. I have no doubt that he will benefit us in ways that we still do not imagine. He exemplifies the ambition of the Oxford Martin School and its interest in solving the problems of the 21st century, and it's a huge pleasure to invite him to address us.
Well, thank you very much for the kind introduction. It's an honor to be here. This is an incredibly beautiful theater, and it's amazing to be in a place designed by Christopher Rand. And speaking of Brunel, actually, I'm a big fan of Brunel, and I have 5 boys, and I really wanted to name one of them Brunel, or Eisenbart. I like them. No luck. Hopefully one in the future. I guess I'll just tell you the story of kind kind of how I came to be here, or the various things that I did, and maybe why I did them, and hopefully that's a bit helpful. And then we're going to have quite a long question and answer session. So I look forward to feel free to ask me any question, no matter how provocative or challenge what we're doing. I'm actually always interested in negative feedback, actually. So the way I started out was I did start out in South Africa, went to Pretoria Boys High, and then left actually by myself initially to go to Canada, and then the US to college. And graduating from undergrad, I had to sort of make a decision, and one path would have sort of led to Wall Street, and I guess quite a big salary, and then the other was to do grad studies and try to figure out a technical problem. And I didn't much like the first one, so I decided to go out to Silicon Valley and go to Stanford and try to work on ultracapacitors for use in electric vehicles. And I do actually think there's potential for a significant breakthrough in that area, and actually to have an energy storage mechanism that's better than batteries. It's not necessary for transport to go electric, but I think it is. It's something that would accelerate that. So I was sort of about to get into grad studies, and then the internet. It was clear that the internet was going to be something that would be very important to the future. So I thought, well, I could either sort of spend 5 years in a graduate program and discover that the answer is that there is no way to make a capacitor work, and perhaps get some nice papers published and that kind of thing, and but that would be a most unfortunate situation, I thought, because you can come to one of the possible things is to determine that success is not one of the possible outcomes. I couldn't actually bracket the uncertainty on that. So I thought I can either do that, or I can work on building elements of the internet. And this was in '95, so nobody had actually made any money on the internet. So but I thought the internet would be something that would fundamentally change the nature of humanity, where it was like humanity gaining a nervous system, where all of a sudden any part of humanity would know what the collective would have access to the collective knowledge, and that's true. It's really quite a remarkable transformation. In the past, you'd have to, and if you wanted access to a lot of information, you had to be near a big library or something, like the Great Bodleian Library nearby, but that'd be the only way to gain access to information. And now with the internet, with everything online, you could be somewhere in the jungles of South America, and if you've got access to an internet connection, you have access to essentially all the world's information, with a tremendous amount of analytical power behind that. So I think it literally has gone from a situation where people would communicate almost like via osmosis. If you can imagine sort of a creature, a simple multicellular creature that would communicate via quite slow chemical signals. And now, any part of humanity knows what every other part of humanity does immediately. It's pretty incredible. So anyway, I wanted to be part of building that, so I decided to do a couple of internet companies, and that actually worked out reasonably well. So the first one helped bring the media companies online, and then we sold that, and then started another company which you may have used called PayPal, and that we sold for actually a larger sum of money to eBay, and that left me in the fortunate position of having the capital to pursue the two other things that I thought would most affect the future of humanity, being sustainable energy, both the production and consumption of energy in a sustainable manner, which I think is arguably the most pressing problem of the 21st century, and then the other one, which is the extension of life beyond Earth. the one I did first was the space company. And the genesis of that is kind of interesting because at first I didn't think that it would be possible to create a rocket company. And I thought what would really make a difference is to have a mission to Mars, a small send a small payload to the surface of Mars that would get the public excited about to reignite the passion for space exploration such that we could go beyond what we did with the Apollo program. And I thought it was quite sad that the Apollo program represented the high watermark of human space exploration. It was not something that I was able to witness in real time because I was -2 when they landed. It just seemed as though that if I thought about the future, one where we were a true spacefaring civilization out there exploring the stars and making the things real that we read in science fiction books and movies, that seems like a really exciting future that sort of made me feel good about the future, and one where we were forever confined to Earth made me feel a bit sad. So that's really what I was trying to figure out is how do we reverse that? And then, like I said, at first I didn't think it would be possible to create a space company because it seemed like the province of governments. But so my first thought was, well, let's see if we can do a philanthropic mission to Mars and get the public excited about the idea of going there, and then that would lead to an increased budget for NASA, and then we could go there. That would hopefully work. So I figured out how to compress the cost of the spacecraft and the communication systems and the payload and so forth. And then it would have been a small greenhouse about 1 meter across with seeds and dehydrated nutrient gel that would land. You'd hydrate the gel upon landing, and you'd have this great shot of green plants against a red background. In the US, that's called the money shot. So the public tends to respond to precedents and superlatives. So this would be the first life on another planet, the furthest that life's ever traveled. And I thought, okay, well, that would get people pretty excited, and maybe they could envision people being there. And we'd certainly be able to figure out a lot of engineering and scientific data about what it took to maintain plant life on the surface of Mars. So I got through most of that, and the thing I got hung up on was the rocket. So getting there in the first place. And there were the US options from Boeing and Lockheed were simply too expensive. I couldn't afford them. And so I went to Russia 3 times to negotiate purchasing an ICBM. Of course, I mean, desperate times call for desperate measures. So, I went there. So I did 3 visits there, and at the end of it, I was able to negotiate a price actually. To buy 3 of these things, 3 of the largest ICBMs in the Russian fleet, but they were still pretty expensive. And by the 3rd trip, I actually came to the conclusion that I was operating under the wrong premise. That I was actually mistaken about the willingness to send people to Mars to expand the space frontier, and it actually. In retrospect, it was quite silly of me to think that people were not interested in such a thing or had lost the will to do this. In fact, people had really thought that it's not possible or not possible for an amount of money that wouldn't materially affect their standard of living. So I came to the conclusion that even if we succeeded in doing this mission, that wouldn't be enough. That would perhaps add a little bit more to the will to do it, but it wouldn't make it clear to people that there was a way. And this is a case of sort of almost the opposite. I think if you can show people that there is a way, then there was plenty of will. So after that third trip, I'd learned a lot more about rockets at that point, and I held a series of meetings, just sort of brainstorming sessions with people from the space industry to try to understand if I was missing something fundamental about the ability to improve rocketry. And this is where I think it's helpful to use the approach, the analytical approach in physics, which is to try to boil things down to first principles and reason from there, as opposed to reasoning by analogy. And the way this applied to rocketry was to say, okay, well, what are the materials that go into a rocket? How much does each material constituent weigh? What's the cost of that raw material? And that's going to set some floor as to the cost of the rocket. And that actually turns out to be a relatively small number. Certainly well under 5% of the cost of a rocket, and in some cases closer to 1 or 2%. And so I call it sort of maybe the magic wand number. So if you had a pile of the raw material, piles of raw materials on the floor, and you could just wave a magic wand and rearrange them, then that would be the best case scenario for a rocket. And so I was able to see, okay, well, there's clearly a great deal of room for improvement, even if you consider rockets to be expendable. And so I think that's what I mean by sort of thinking about things from a first principle standpoint. If on the other hand, I sort of analyzed it by analogy and said, okay, well, analogy would be, well, what are all other rocket companies, what do their rockets cost? What historically have other rockets cost? And that would be sort of an analogy thing, but it really doesn't illustrate what the true potential is. And so I think it's sort of a first principles approach is a good way to understand what new things are possible. So this is a good framework. And it doesn't mean you'll be successful, but at least you can determine if success is one of the possibilities. That is important, I think. So started SpaceX, and initially had decided to make a small rocket called the Falcon 1 that was capable of putting about half a ton into orbit. And this did not go smoothly. I just want to. And it was quite difficult to attract the key technical talent, and of course I was quite ignorant of many things and made lots of mistakes along the way. And the first 3 flights of the Falcon 1 failed, or rather they certainly didn't get to orbit. The second and third flights arguably got to space, but they did not reach full orbital velocity. And then fortunately, the fourth flight worked. And if it hadn't, SpaceX wouldn't be around, because I'd basically run out of money. So that was a bit of a nail biter. And thank goodness. And in fact, this all happened in 2008. So there was really no ability to raise outside money in a meaningful way in 2008 because of the financial crisis. So you can imagine trying to go to raise money, saying, well, yes, we just had 4 failures and the world is in financial ruin, but would you like to give us some money? That would be a definite no. So fortunately that succeeded, and we were able to go from Falcon 1 to begin designing the Falcon 9, which is an order of magnitude larger vehicle, and in fact has more than 20 times the payload. So it's got a payload to orbit of over 10 tons, and that actually has gone a lot better because we had the experience of Falcon 1 to go by, and part of the reason we started with Falcon 1 was because I thought we would make a lot of mistakes, and if we're going to make a lot of mistakes, then it's best to make those mistakes at a small scale rather than at a large scale. And that seems to have worked because going to Falcon 9, we've had 4 flights of Falcon 9, and they've all all 4 of them have been successful. So I think that principle seems to have worked reasonably well. You know, touch wood and all that. Flight 5 is coming up soon. And then we also developed the Dragon spacecraft because somewhat opportunistically, NASA announced that they were going to retire the space shuttle, and they didn't have the budget to develop a cargo transport capability to the space station via the normal large government way, and so they put it out to bid to commercial industry for the first time in NASA history. It was quite a big step, and we were lucky enough to win one of those contracts, and then the other company wasn't able to execute, and so they got cut, and so we ended up being the primary means of transporting cargo to and from the space station. So we just did the first 2 missions, the first 2 space station resupply missions this year, and thankfully both of those worked. And then going from there, NASA then said, well, what about astronaut transport? And so they put out a big competition and awarded 2 contracts for astronaut transport, one of which went to Boeing. They got a slightly larger contract, and then one to us. And so hopefully in about 3 years, we will have Dragon version 2 and the next generation Falcon 9 rockets transporting astronauts to and from the space station. Then we've got Falcon Heavy, which is about 3 times the capability of Falcon 9, and that will hopefully launch in about a year or 2. That'll actually be the most powerful rocket in the world by a factor of 2. So we're making sort of steady progress. The Falcon Heavy, to put that into perspective, has about 60% of the capability of the Saturn V moon rocket. So if you were to combine 2 flights of Falcon Heavy with orbital rendezvous and docking, you could actually send people back to the surface of the moon. So I think now we're really sort of talking about, you know, advancing the frontier, which I think is quite important. And then the really major breakthrough that's needed in rocketry, the pivotal one, which we're aspiring to make, is to have a fully and rapidly reusable rocket. This has not been achieved before. The space shuttle was an attempt to achieve that, but it was not a successful attempt, unfortunately. The main tank of the space shuttle was thrown away every time, which was also the primary ascent aeroframe. And even the parts that were reusable were so difficult to reuse for the space shuttle that it ended up costing 4 times more than an expendable rocket of equivalent payload capability. It was the right goal, but didn't hit the target. And I think this is actually incredibly important. I think it may not be completely intuitive, but I think perhaps if one refers to other modes of transport, it makes more sense. Because all other modes of transport are fully and rapidly reusable. And that applies to a bicycle, a horse, plane, ships. In fact, in sort of normal life, it would be quite silly to discard your horse after every ride, or dump the plane after you flew it. The cost of a 747 is about $300 million, and you'd need 2 of those to do a round trip from Los Angeles to London. But I don't think anyone has paid $500 million to do that. So, nor would one want to. I mean, there'd be a lot of travel by boat and train and that sort of thing if that was the true cost. So it's extremely important in rocketry to achieve full and rapid reusability. This is not an easy thing to do because of Earth's gravity well and just the basic physics of things. So there have been many attempts to create a reusable rocket, but they've generally, they've all sort of been cancelled along the way once people realized that they would not succeed. In fact, usually they got cancelled quite some time after it was obvious they wouldn't succeed. but the essence of the problem is that if you design an expendable rocket and do quite a good job of it, you'll get 2 to 3% of your liftoff mass to orbit. Then if you say, well, how much mass is needed to return that rocket and be able to fly it again quickly? Well, about 2 to 3%. So you can basically get nothing to orbit, is the way it's been in the past. So in order to do something useful, what you have to figure out is how do you get a much larger percentage to orbit, let's say ideally on the order of 4% of your liftoff mass to orbit in an expendable configuration, and then compress the reusable elements down to about 2%, so you have a net payload to orbit of 2%, and then you could really have something that's quite useful. And the cost of the propellant is only about, let's say, 0.3% of the cost of the vehicle. If you take Falcon 9, for example, which uses quite expensive fuel, relatively speaking, I think there are lower cost options. The cost of refueling or reloading propellant on Falcon 9 is about $200,000, and the cost of the rocket is $60 million. So it's just like a plane. I mean, it's just, if you were to refuel a plane, not very expensive. If you want to buy a new plane, very expensive. At this point, I'm really reasonably confident that it can be done, and now it's a question of executing to make that design work, and seeing if there are any gotchas. And there'll probably be a few craters along the way, so I'm not expecting this to be a smooth journey. As long as the rocket doesn't land on anyone, it'll be fine. So that's really what SpaceX is focused on right now, is kind of scaling up the size of the rockets and trying to achieve this full and rapid reusability. So if you're curious, you can just, we're fairly public about things, and you can just follow it on the SpaceX website. So that's what we're doing on the SpaceX side. Then in parallel, we've got Tesla, which is developing electric vehicles, and so sort of a whole separate storyline. And tell me if I'm going on too long, and stop me at any point. Feel free to leave if it's getting boring. I won't be offended. So with Tesla, the goal is to try to create electric vehicles that are more compelling than gasoline vehicles as a product. I mean, the fundamental issue we have in energy and transport is the tragedy of the commons. You know, we've got the CO2 capacity of the oceans and atmosphere that is unpriced, or mostly unpriced. And so it's almost like we're sort of dumping garbage in the atmosphere, and nobody's paying for garbage collection. So it's a most unfortunate situation, because there are quite significant vested interests in oil, gas, and coal, with enormous amounts of money. It's quite a difficult battle to fight, and you can't expect them to simply roll over and commit suicide or something. They will fight it hard, and they have been. And so, unfortunately, it requires fighting hard back and creating products, in the absence of there being a tax on CO2, creating products that don't rely on the relative economics of using hydrocarbon fuels versus electric cars. And so that was our goal from Tesla from the beginning. And I'm really I'm excited to see that we've achieved that goal, actually, with the Model S, which was, as was mentioned, the Model S was recently awarded top honors by, it was awarded sort of Car of the Year and Automobile of the Year, and that was against a very difficult field of gasoline cars. And so I'm hopeful that this will be seen as a pivotal moment in transport, where people finally appreciated that an electric car could be better than a gasoline car. And then going into the future, our goal with Tesla is to keep refining the technology, increasing the scale of production, and make a mass market electric car that almost anyone can afford. That's step 3 on the strategy. So step 1 was a high price, low volume. Step 2, mid price, mid volume. Step 3, low price, high volume. So we're sort of at step 2, and now we want to progress to step 3 as soon as possible. And we did get quite a bit of criticism at Tesla for creating the Roadster, which we did in collaboration with Lotus. And people were complaining, well, why are you making this expensive sports car? And with the implication that we felt there was a shortage of sports cars for rich people, and we're racing to meet that unmet need, you know. So the real reason is that any car that we make at low volume, which is the first version of technology, is going to be expensive. It didn't matter what that car looked like. So we could make something that looked like a very standard, you know, sort of Toyota Corolla or, you know, Ford Fusion or something like that, and it would have cost, say, $70,000. But nobody will pay that for what looks like a mid-size economy sedan. They just won't, or very few people would. But people are willing to pay $100,000 for a fast sports car, and so that's why we started off at that level. And then with another big design iteration and an increase in volume, so we had economies of scale, we were able to create the Model S. And then with another order of magnitude increase in volume and another big design revision, that's what will allow us to cut the price in half again. And then Tesla also supplies powertrains to Mercedes and Toyota, and perhaps will do that for other car companies in an effort to help them accelerate the transition to electric vehicles. So that's Tesla and SpaceX, and I should mention certainly SolarCity, because one must generate electricity in a sustainable way as well as consume it in a sustainable way. And people will say, well, what don't electric cars create pollution at the power plant level? It should be noted that for any given source fuel, it is always better to generate the power at the power plant level and then charge electric cars and run them for any given source fuel, because power plants are much more efficient at extracting the energy than internal combustion engines in a car. They're at least twice as efficient, and usually more like 3 times as efficient. So for any given source fuel, it's always, you know, even if the whole world were always going to be powered by hydrocarbons, it would still make sense to do electric cars. But of course, we must find a sustainable means of generating energy as well. And I think that the most likely, well, the main candidate for energy generation is actually solar. I think the physics of this is actually rather obvious, because the Earth is actually almost entirely solar powered today as it is. Would be a frozen ice ball at, I don't know, 3 or 4 Kelvin, if it weren't for the sun, and our entire system of precipitation is powered by the sun. The ecosystem is almost entirely 99.999% powered by the sun, except for some chemotrophs at the bottom of the ocean. So that's it's rather obvious that I think one should try to take a little portion of that energy, and it's actually not much, and convert that into electricity for use by society. So I'm quite confident that solar power will be the single largest source of energy, or electrical energy, for humanity in the future, and it will be combined with other things, of course, such as hydropower and geothermal, and I actually think nuclear is not a terrible option, as long as you're not located in a place that's susceptible to natural disasters. That's also, I think, defies common sense. But so as long as there aren't huge earthquakes or sort of weather systems that have names coming at you, then I think nuclear can be a sensible option. And there are much safer and better ways of generating nuclear energy, I'm talking fission here, than existed in the past when nuclear reactors first came out. And then at some point in the future, it'd be nice to make fusion work, of course. That would be quite good. But in the meantime, I think indirect fusion, being solar power, is a good thing to do. And so that's what SolarCity is doing, is really trying to improve the economics of solar power. And they're doing a great job. I don't run the company, so the credit for SolarCity really goes to the two key guys who run that company. But they're doing a great job of really accelerating the adoption of solar power in the United States. And hopefully they'll come to the UK as well. So that's about it. So we can go to Q&A.